good morning, good afternoon, everyone, and welcome in across the continent for another very exciting Exploring by the Seat of Your Pants broadcast. If you're joining us for the first time today, like so many of you are, we're all about bringing conservation, adventure, and science into classrooms around the world, and everything we do goes to our YouTube channel. So if you want to check out this program in 3 weeks or 3 years, check out like 4,000 other programs we've done over our 11 years of operation, you can head there and do just that. Now, before I bring in our speaker du jour, I want to note we do have a Kahoot today. So between our talk and our Q&A, if you want to play along with a little 4-question quiz, you can pull up this game pin in a separate tab, and we'll be getting to that in about 25 minutes. So excited to have you play along. Now, of all the programs you could have joined us for, I'm so happy you're joining us for this one because this marks the beginning of, I think, year 5 of our amazing Peak Discovery series in collaboration with the amazing mountain parks in Alberta and British Columbia, Canada. These are some of the most special places, not just in our country, but in the entire world, which is why we have such a big American audience today. So welcome in from across the continent. So exciting to have you all. Now, today we are going to start with a little bit of a deep dive into the magic Waterton Mountains, some of the creatures, the habitats, the amazing things that they've got on the go there with Shani. So Shani's going to take us away, and I'm so excited for you to ask all sorts of questions at the end. Without further ado, welcome back to the broadcast, and take us away. Can't wait.
Awesome. Well, hello, everyone. Thank you so much, Jesse, and thank you so much, everyone, for joining me today. As Jesse said, my name is Shani, and I've been an interpreter here for about 3 years now. Now, Waterton is a very important place, and it has been for a very long time. We acknowledge that we're in the territories of the Siksika Sitapi, the Kainai, Piikani, Siksika, and Amskapi Piikani. Waterton Lakes National Park falls within Treaty 7 territory, which also includes the Tsuut'ina Nation, Stoney Nakoda, Bears Paw, Chiniki, and Good Stoney. The Tunaka Nation also have a connection to Waterton, and we recognize the Métis Nation of Alberta District 1 have Métis Nation members residing in the area. The lands and waters of Waterton have been used for millennia by Indigenous peoples for sustenance, ceremony, trade, and travel. We thank them for their continuous stewardship and for sharing the land with us. Now, today I want to talk to you all about a really awesome ecosystem here in Waterton, the subalpine ecosystem. Now, the subalpine is an area near the top of the mountains, and because of that, it experiences harsh, exposed conditions like cold weather and strong winds. So only the strongest species can live up there. And one of those strong special species is the 5-needle pine trees. Now, there are 2 types of these 5-needle pine trees here in Waterton, the limber pine and the whitebark pine. And both of these special species are very important because they help so many other parts of the subalpine ecosystem. Now, I think it would be really, really awesome to check out these cool trees and the ecosystems that they live in today. And since you're all joining me from all around the world right now, which is so cool, it makes hiking up together a bit difficult. But I do have another solution. I found out this summer that the mountains in Waterton have magical powers. And when a big group of an imaginative, enthusiastic people get together, their powers are activated. The mountains are so powerful, in fact, that their magic will transfer through all of our screens today and allow all of the rooms that we're all in right now to transfer into different subalpine creatures. And all we have to do is say a spell all together. So I'm going to say this spell line by line, and then I'm going to wait for all of you to repeat after me in your classroom.
Woohoo.
But first things first, we have to think of an animal that would allow us to soar way up high in the sky. So this is where you guys come in. So type into the chat any animals that you think would allow us to soar high up into the mountains.
I started with this. And I've got eagles. I've got eagles up. We've got kites. Let's see what we've got. Any other creatures that you can share? We'd love to hear from you. Blue Jays. Yes, if anyone's a Blue Jays fan, Toronto Blue Jays going to the World Series. Very, very good. Keep sharing those animals. What do we got? We've got blackbirds. We've got all sorts of cool birds, Shani. That's fantastic. Way to go.
Awesome. You're all on track. Absolutely. It's birds. Birds will help us soar up high in the sky. And I have just the spell for that. So repeat after me, everyone. Dear Magic Waterton Mountains.
Dear Magic Waterton Mountains.
We want to go way up high in the sky.
We want to go way up high in the sky.
And to do this, we must learn to fly.
And to do this, we must learn to fly.
So please give us some bird wings.
So please give us some bird wings.
So we can explore all the subalpine things. Amazing, it worked. Look at those bird wings. And these look like the wings of a Clark's nutcracker bird. That's absolutely perfect because Clark's nutcrackers love the 5-needle pine trees. So we'll probably all be brought right to one. Now, bird wings rely on something around them in their environment to help them fly, the air. The air is very light, so if birds get enough of it under their wings, it lifts them up. And there's a lot of us here today, which means we're going to need a lot of wing power to get that air under our wings. So I want all of you in your classrooms to put out your wings and start flapping them out in front of you. Perfect. Get those wings going. Oh, the Clark's nutcracker is moving its wings as well. Awesome. Keep going. I think it's working. Look, and we're flying up into the sky. We're taking off. Amazing. And we're starting to soar up this mountain. How cool. Now, these dead trees that we see in front of us aren't the 5-needle pines. We're not high enough on the mountain for them to be growing yet. They're actually lodgepole pines that were burnt in 2017 by a wildfire. Now, I think I can see some trees that didn't burn further up, though, and maybe these are the 5-needle pines. So let's keep going even higher to see them. This time we don't have to flap our wings as hard, though. We're already up in the air, so just glide. Glide with your wings out to the side. Perfect. We're gliding, and we've made it so high up the mountain that we can see these trees further up that didn't burn in the fire. Now, most of these trees that we're seeing are still lodgepole pines, but I think those gray ones that we're seeing are the whitebark pines and the limber pines, but they kind of look like they're dying, unfortunately. We can see that there are less trees growing up here than there was further down because of the harsher conditions in the subalpine that we were talking about earlier. And it looks like these trees are growing in small patchy groups or islands. Now, each of these islands is made up of both 5-needle pines and lodgepole pines. And that's because 5-needle pines are what we call pioneer species. This means that they're some of the toughest trees that can withstand the harshest, windiest conditions, so they're usually the first species to start to grow in an exposed area, like the subalpine. They then provide cover and a windbreak, so other species, like the lodgepole pines, can start to grow next to them. And look, we can even see that there's some 5-needle pine species going right out of the rock face. Now, their roots are so strong that they can grow directly into the cracks of the rock face. And this actually prevents erosion and rock slides because their super strong roots hold everything together. I wonder how high up these trees can grow on the mountain, and I really think we should find out. So get your wings back, get those wing power, and flap as hard as you can this time. As hard and fast as you can. Okay, look, we're flying so high up. Look how tiny those trees are down there now. Awesome. Okay, now we're starting to stop though. And oh no, now we're starting to fall down. Okay, it's okay. Okay, we landed. It's all right. And it looks like we've landed on a 5-needle pine tree. That's awesome. We're pecking open the cones of these trees. Now, Clark's nutcrackers love to eat the nutritious seeds that grow inside the cones of the 5-needle pine trees. And they especially love the cones from the whitebark pines, which is very important for these trees because their cones actually don't open naturally by themselves. They can only be opened by the specialized beak from the Clark's nutcracker. That means that without the Clark's nutcracker, no whitebark pine seeds would have the chance of growing into new trees. You see, after Clark's nutcracker strategically opened the tightly sealed cones they can hold anywhere from 50 to 100 of these pine seeds in their special throat pouch at one time. They can then travel up to 20 kilometers away to stash these seeds in caches for safekeeping. Each year, one bird can stash up to 100,000 seeds in 20,000 caching locations. Now, can you imagine remembering 20,000 hide-and-seek spots? Clark's nutcrackers do have a really good memory. But they still forget some of their caching spots, which means the ones they forget have a really good chance of sprouting the next year and growing into trees. So the five-needle pines help the birds out by giving them food, and the Clark's nutcrackers help the pines out by spreading their seeds. What a good partnership. Okay, look, we're starting to fly. We must have gotten enough seeds. So let's all put our wings out again and look for a good caching spot. Okay, this area does look like a good wide open space to land. Because remember, five-needle pine trees are pioneer species, so they love to grow in wide open spaces. All right, perfect. Let's land. So everybody make sure your feet are stable on the ground and your arms are out for balance, because this is a big bird we've got to land. Okay, we're landing. We're almost there. Perfect. We've landed. And we may have just helped a five-needle pine tree grow. How cool. Now, this makes me wonder if there are other creatures that also rely on these trees up here in the subalpine. So let's use some magic to find out. Repeat after me one more time. Dear Magic Waterton Mountains.
Sorry, dear Magic Waterton Mountains.
We've seen the relationship between the bird and this tree.
We see the relationship between the bird and this tree.
If there are other relationships we want to see.
If there are other relationships we want to see.
Perfect. We did it. And look at our paws and claws. Okay. Does anyone in the audience today know what we've turned into this time? I want you to type your answers of what you think we are into the chat.
Miss Eibel's class, you guys, if you want to flick on your mic, we can come to you live as well. Mr. Olson's class, you guys too. What do we think? Who's got big paws like that? What do we think? Oh, in the chat, everyone's got their hands up. We got to yell it out. We got to flick on your microphone. Oh my goodness, bears in the chat. Bears. Yes, a grizzly bear.
Yes, absolutely. A grizzly bear is exactly right. Now, we can tell that these paws are specifically from a grizzly bear because of the length of the claws. You see, grizzly bears evolved in the wide open prairie landscapes, so they needed long claws to dig for their food sources like plant roots, bugs, and ground squirrels. And on the other hand, black bears evolved in a forested landscape, so they have shorter, more curved claws that help them climb trees and escape danger. When humans started building houses on the flat prairie land, grizzly bears got pushed out of those areas and started living in the subalpine instead. But grizzly bears can still use their long claws for digging up in the subalpine too. In fact, they like to dig for the five-needle pine seeds cached by the Clark's nutcrackers. And it looks like we're starting to waddle around to find a caching spot. So everybody join in, start waddling around. Okay, now we're digging. Everybody start digging. We've got to dig for those seeds. Hopefully we can find some. It doesn't look like we can find any seeds here. Okay, let's waddle again. Everybody waddle around like a big grizzly bear. Okay, now dig again. We found a spot. Dig, dig, dig. No seeds again. This is weird. Something's up. Earlier, we saw that a lot of the five-needle pine trees in the mountains were dying, and now we can't find any of the seeds. Now, I know there's many things that are threatening the five-needle pine trees, but let's find out the biggest reason why they're struggling. It's time for another spell. Repeat after me. Dear Magic Waterton Mountains.
Dear Magic Waterton Mountains.
We can't find the seed supply.
We can't find the seed supply.
Transform into something that can show us why.
Transform into something that can show us why.
Perfect. Okay, look, we've shrunken down into a super, super small and very mysterious creature. We do look like the spores of some type of disease. And I do know of one disease that is harming five-needle pine trees that's called blister rust. But we're on a flat, broad leaf and not skinny needles like the five-needle pine trees have. So maybe we aren't blister rust? If only we could fly like we did earlier as the Clark's nutcracker. Then we could see what's happening all around us again and maybe get some hints about what we are. Okay. let's think back to what we learned about flight earlier when we were a bird. Does anyone remember what we needed to pass under the bird to help it fly? Shout out in your classrooms.
Shout it out. Shout it
If
out.
you said air, you're absolutely right. Our bird wings needed lots and lots of air to pass under them and lift them up because it was so big and heavy. We are much smaller and lighter now, so we only need a little bit of air to lift us up, but we don't have wings to move the air around this time. Can anyone think of something else that pushes the air around in nature? Shout it out in your classrooms again.
What do we think? Cool. Okay.
If you said wind, I think you're right. That could be just the lift we need right now. And luckily, Waterton has a lot of wind. And here it comes. There's the gust of wind we needed. We're off and we're flying again. Woohoo! This is so fun and relaxing. Okay, everybody float around for a minute like you're a spore. Now, this gust of wind is taking us pretty far. I wonder where we're flying to. Keep looking closely and shout out in your classrooms if you see anything in the distance. Oh, look. There's a tree, and it looks like a 5-needle pine tree. I think we're even entering into the needles. We probably are blister rust then. After blister rust enters a 5-needle pine tree through its needles, it goes through a lot of steps before it fully infects the tree. These steps usually take a few years to complete, but with a little bit of magic, we can speed up time so we can see what these spores do to these trees in a couple of minutes. Now, shortly after infection, the needles start to show yellow-orange spots. That's the first sign of infection, just like we see here. Branching mycelium then grows from the spores in the needles to the branches of the 5-needle pines. Now, does anybody notice something else that's moving around in this tree branch? Type in the chat if you have any ideas what those are.
Kind of look like sugar cubes to me. Delicious. Delicious.
Absolutely, Jesse. Yeah, you got it. They are sugar cubes. Now, the beige tubes on the edges of the branch are called phloem channels. They act like the highways of the tree, transporting sugars around, giving it the energy it needs to survive and grow. Now, unfortunately, the blister rust eventually grows all the way around the branch and blocks these channels, just like we see here. This causes the branch to swell up around that sugar buildup, just like we see here. This branch will eventually die, and it turns the needles completely orange. Now, a year or two after the canker forms, a yellow fruiting body starts to grow from the blister rust and bursts through the bark of the tree. So we can see these right here, and those are called blisters. And if you rub it with your finger, it actually looks like Cheetos dust because it's filled with tiny yellow spores that are ready to fly in the wind back to the flat leaf plant we started on at the beginning to start the life cycle all over again. Now, the blister rust takes anywhere from 3 to 6 years to grow around the main stump of the tree, and then sadly, the tree fully dies. We've got to get out of here to be a part of the solution and not the problem. But how? Oh, right, magic, duh. Okay, let me think of a spell for this one. Okay, I've got it. Repeat after me.
Here we go.
Dear Magic Waterton Mountains.
Dear Magic Waterton Mountains.
Blister rust is bad.
Blister rust is bad.
This I know for sure.
This I know for sure.
Turn into something that has a cure.
Turn into something that has a cure.
Oh, look at that. We've turned into a human. And we have gloves and a Parks Canada uniform on. We must be a Parks Canada researcher. And we're with an entire team of Parks Canada researchers hiking up in the subalpine. Now, Parks Canada is working with other organizations like the Whitebark Pine Ecosystem Foundation to try to stop the spread of blister rust in 5-needle pines. In the last 100 years, Western North America's whitebark pine population has decreased by over 50%, mainly because of blister rust. This rate is even higher here in Waterton at 97%. But that's why the work that Waterton researchers do is so important. You see, to fight blister rust, researchers need to find 5-needle pine trees that have already been infected by blister rust, but are naturally resistant to this disease so that they can study and spread their genes. And because Waterton has such a high infection rate, healthy-looking trees are probably not just healthy because they haven't been exposed yet, but because they've actually fought the infection with their natural resistance. And it looks like we've found our first tree to inspect for signs of blister rust. Everybody look at the colors on this tree's needles. Some of them are turning orange, which means they're dead. Right off the bat, that's not a good sign. But branches can die for many reasons, so let's check a little bit closer here. We're looking for signs of cankers or blisters. And oh no, it's some of that Cheetos dust like we saw earlier. This tree is definitely not resistant. We have to keep looking. So everybody march your feet like you're hiking. We're back on the move again to find a possibly resistant tree. And it does look like we have a contender here. Our colleague Paul is doing an inspection right now to make sure that this tree is resistant. Once trees pass the first inspection test, they get their very own tag and identification number. But to make sure that they are actually resistant, they have to be tested further in a controlled lab environment. Don't worry, we don't have to hike this entire tree back down the mountain. Instead, seeds are collected, since they would carry the same resistance as their parent tree, and they're a lot easier to fit in a backpack. But there is just one problem. Remember when we were the Clark's nutcracker and bear earlier? We loved to eat the 5-needle pine seeds. So, to be sure that these animals don't harvest all of the seeds from these possibly resistant trees, parks researchers put cages around some of the cones when they're first developing in the springtime to save them for later, just like we're doing here. Now, these are limber pine cones because they're yellow-brown in color, whereas the white bark pine cones are purple-brown in color. Another difference between the two is that the white bark pines are often found at higher elevations, which means that we've got to get hiking again to find some of those. So everybody march your feet. We're hiking higher up into the subalpine. Look how high up this mountain we're going. And we've made it to a tree. Wow. Here we can really see another difference between the white bark pine and the limber pines. The white bark pines can grow a lot taller. That means that Parks Canada researchers need to throw a rope to the top of the tree and then climb all the way to the top of these potentially resistant trees to get their cones. So we're all suited up. Everybody, let's help this Parks Canada researcher climb. Use your arms. And I hope nobody's afraid of heights.
No one's afraid of heights. We got this.
Don't look down. Don't look down. Okay. It looks like we've made it to the top. Look how beautiful it is up here. So let's get caging these cones, just like we did with the limber pine cones. After these cages are inserted, the seeds are then left all summer to grow under the cage's protection. Oh, look, the weather's changed. Parks Canada scientists then hike back up in the fall to collect the mature cones, just like we see here. We can already see the harsh, snowy conditions that these trees start to face in early fall. Let's imagine what happens next to these cones. When the seeds are collected, they are labeled with a parent tree identification number. They're then sent to a tree nursery where they're planted. And they slowly start to grow. This seedling here is about 2 years old. Now, most of the seedlings from each parent tree continue to grow in the nursery for a few more years to hopefully be planted back in the subalpine later. But a small number of these seedlings from each parent tree are sent to a research lab where they're tested further against blister rust. To do this, shelves like this one are used. Blister rust infected ribes plants, so the plant that we started on earlier as blister rust, are placed on the top shelf, and the seedlings are placed on the bottom shelf so that blister rust spores can fall onto them, infecting them, just like we see here. They're then carefully watched for about 4 years to see if any signs of blister rust develops. Now, a lot of these seedlings do develop blister rust and die, but a rare few of them do survive, which means that their sibling trees growing in the nursery and the parent trees growing in the wild are resistant too. The sibling trees can be replanted in the wild, but they won't produce cones for at least 50 more years. This makes the parent tree who can produce cones extra important, and researchers want to make sure that they are kept safe and produce seeds that can grow future resistant trees for many generations. But it would be a lot of work to constantly be hiking up into the alpine to check on the parent trees and collect their seeds. So instead, they make a graft from them. Now, this grafting process is like how a surgeon would reattach someone's leg in a hospital. First, they find a small branch from the resistant parent tree in the wild. They then cut off this small branch from the parent tree and then attach it to the base or rootstock of a young sapling that is about 5 years old. These grafted trees act like 50 to 100-year-old mature trees, producing cones. But they're still small enough to fit in an orchard where researchers can monitor them and harvest their seeds for replanting. It's the best of both worlds. We have one of these orchards in Waterton filled with grafted limber pines that the Whitebark Pine Ecosystems Foundation has provided us. Here we can see the graft and the cone that's starting to grow. Once more of these trees start producing cones, their seeds can be planted out in the subalpine to spread these resistant genes and help restore a healthy population of 5-needle pine trees. We might have to bring the mountain magic back again out when that happens. But for now, I think we all deserve a break. So let's return to our normal form with one last spell. Repeat after me. Dear Magic Waterton Mountains.
Dear Magic Waterton Mountains.
Thank you for helping us explore.
Thank you for helping us explore.
Please return to how you were before.
Please return to how you were before.
Perfect. Great job, everyone. We did it. The Magic Waterton Mountains have brought us back to our human form safely. Thank you so much for making this adventure possible with me today. Please give yourself a big round of applause in your classrooms.
Way to go, everybody. Shani, this is so much fun. I've never done a 4-spell broadcast before. It's a first in the history of exploring by the seat of your pants. We're going to dive into begin, everybody, with a little Kahoot to see who's paying attention and have some fun around some of the cool things you learned today. And then I'm coming to you. So Ms. Ibel's class, Mr. Alston's class, all our friends on YouTube, please feel free to start sharing questions and we are going to get underway. But for those who are new to Kahoot, the faster you answer, the more points you get. And what you win is Shani and I's everlasting respect. So if you can't get in for whatever reason, you can just yell out the answers in your class as we go along. But we are going to get underway with this very shortly and get underway. All right. And then Miss Ibel's class, we're coming to you first. Your climbing and hiking and spell skills were awesome, by the way. Getting to watch you in the background. You rock. So let's get started. Do this thing. You can start after we've gotten underway. That's totally fine. And Shani, if you want to help us out with any hints along the way, you're welcome to do so. We'd love to have any extra assistance as we go along.
Sounds good.
True or false? 5-needle pine tree seeds help animals like grizzly bears and Clark's nutcrackers by being a nutritious food source. So are these seeds nice and healthy and good for all the animals? Yes or no? Got one answer in. Get your answers in. All right. We've highlighted them a lot today. Let's see what we've got. 7 more seconds. I mean, we'd have a different broadcast if they weren't. We wouldn't be talking about them probably. So yes, our correct answer is, of course, true. Way to go, everybody. Okay, Fuzzy Dragon has our lead. Rockstar Camel just behind. Let's go to question 2. This is a quiz. How do the 5-needle pine trees help the other plants in the subalpine ecosystem? Big words, but how do they help the other plants? Is it they scare off all the other plant eaters? They can inhabit exposed places first and provide shelter for other plants? They don't. Or their seeds provide food to other plants too. The other plants come and munch their seeds. I don't know. Let's see what we've got. Tough one, bit of a tough one. So yes, in these exposed places, these weird places that other plants can't grow, they can grow there, and then other plants can sort of build up a little ecosystem around them. Very, very cool. Fuzzy Dragon nailed that one. We'll see as we go to question 3 what we can get. How are Parks Canada researchers helping stop the spread of blister rust in 5-needle pine trees? These are the challenges that these trees are facing. Are they doing intensive genetic engineering? Are they burning down the forest where the blister rust is present? Are they finding naturally resistant trees and spreading their seeds? Hint, hint, nudge, nudge. Or they have no idea how to stop it. They're throwing up their hands. They're hoping for magic spells and they're walking away. What do we think? So, yes, our answer is number 3, finding those naturally resistant trees. Way to go, everybody. Fuzzy Dragon running away with it. But we go to our final question. Waterton Lakes is part of an international peace park with. We did not talk about this, but I wanted to highlight it. What park in the U.S., right across the border from Waterton, is it a joint park with? Now, we've talked about this in past broadcasts. If you want to check them out, the answer is on our YouTube channel. Is it Grand Canyon, Glacier, Everglades, or Yellowstone? You get to learn about all sorts of national parks today across North America. The answer is Glacier. So for whoever got that right, way to go. Let's see what our leaderboard is. And then we are going to head to Miss Isla's class for our first question in Belleville. Bayside, we're coming to you in a sec. Rockstar Camel is 3rd. Adorable Clam is 2nd. And first, for all the marbles, I think it's our dragon friend. Way to go, Fuzzy Dragon. If you are any of these folks, let us know who you are in the chat. We'd love to hear from you. And we're going to dive in and get underway. So, Miss Isla's class, Belleville, we're going to come to you first. Unmute your mic and take us away with the first question. Hey, guys. Hello. Hello.
Hi.
Hello, guys. Does anyone have a question?
Questions?
Okay, go ahead. Jaden, go. Speak, honey.
How were pine needle seeds invented?
How do they get started? How do we end up with pine needle seeds, Shani?
Pardon?
How did we end up with pine needle seeds? Like, how do we end up with these things to begin with? How did they evolve, I guess?
Ooh, good question, Jesse. So pine needle seeds are actually just a way of the tree to help spread the seeds, right? And the cones that are around them protect them. And so that's why the trees evolved to have them, to be able to protect those seeds inside.
Yeah, it's a very cool question. It's a very deep question. You'll be covering more of this in grade 11 and 12. You're like 10 years ahead of the ball game. So way to go, Ms. Ibel's class. Mr. Alston's class, we'd love to come to you. Flick on your mic. I'll make sure you're all there and good, and we'll come and check in a second. Shani, you've got a question from YouTube, and that is, how does someone end up being you? If someone wanted to be you when they grew up, what would they do in school to end up there?
Yeah, that's awesome. I love this question because as an interpreter, there's so many different paths to be able to get to this position. I went to school for biology, but a lot of my colleagues actually went to school for things like theater, things like the arts. And so there's so many different ways to be able to get into this position. But you can also volunteer at a lot of like outdoor organizations as a student. Or maybe convince your teacher to come for a field trip to some of the outdoor education areas in your area.
Yeah, excellent start. I remember as a boy going to all sorts of Parks Canada and Ontario Parks programs. It's one of the most enriching and amazing experiences of my life. So if you get the chance, wherever you may be located across Canada, the US, go hang out with the Parks teams. They're the most enthusiastic, wonderful people you will ever run across. Shani, we highlighted some cool stuff that scientists are doing, hiking in these remote mountains, climbing all sorts of things, defying danger at every turn. How many scientists are on your team? Do we have a figure of how many people are in Waterton Lakes?
Yeah, that's a really good question. So I think in the summertime, we have about 150 people that are on staff, which is really awesome. On the white bark pine team, there's only 2 or 3 people actually that are working on it in park this year. But we also have lots of cool other scientists that work on aquatics in the park, work on preserving our grasslands, things like that. So it's a really awesome team that gets to work together here.
Super, super cool. All right, we're going to head to YouTube for another one. And then Ms. Ibel's class, we're coming back to you. Anyone who wants to chime in the chat, please do. Don't be shy, everybody. What is the most difficult thing about combating the rust? Like, is it actually getting out to the field sites? Is it finding the seeds to plant them? Is it bringing them back out when we're done? Anything you can share with us?
Yeah, absolutely. So the most difficult part is just that a lot of the trees, unfortunately, do end up dying. When trees are infected with blister rust, about 99.9% of them do end up dying to the disease.
Wow.
And so the hard part is just checking a bunch of these trees for that blister rust, and taking a long time to actually find the ones that are resistant. But thankfully, they're out there. That 0.1% is out there.
This is something that we see in a lot of conservation things. So coral reefs, we often find the individual coral animals that sort of withstand heat the best, and then we replant those and we replant coral forests. So when you find the most adapted things to changing environments, they can go a really, really long way. We've been doing this with species for thousands of years as people, and it's really exciting to see it in a conservation context. So cool question, guys. All right, Bayside, we're coming back to you. Flick on your mic and take us away with a second question. You're good to go.
Mine's come sticky.
Why are pine cones sticky?
Oh, that's a really good question. I actually don't really know the answer to that one. Does anybody else have any ideas?
I don't
we can
know.
put them in the chat.
We might be stumping the scientist here, which is always a great thing that happens in exploring by the seat of your pants. Insofar as they're sticky, it might be to connect to something's fur or feathers so that the seed can be transported a little bit further. So all plants want their seeds to end up far away. They don't want all their seeds to just land at their base, because then all the babies would be like competing with mom to grow. So there's a lot of ingenious tactics that plants have developed over 400 plus million years to help get their seed to far. I would expect it's that, but I can't say specifically. We'd have to find a cool tree biologist to come on, and we'll do that next time. Great question, guys. All right. You highlighted grizzly bears. We became a grizzly bear for a little bit. Do the researchers have to worry about grizzly bears when they're in the field? Is there any kind of precautions that they have to take? Share a little bit more.
Yeah, absolutely. So anybody who's going out in the field here definitely does bring bear spray on them. It's always a good thing to have when hiking out in bear country, but that is a preventative thing. Bears, they want to stay away from us. They're afraid of humans more than we're afraid of them. And so they do want to stay out of our way. The best way to kind of warn them when we're there is just to talk with your colleagues when you're out, or talk with your family if you're going out for a hike. And then that lets the bears know that you're in the area. They know that you're a human, and they're going to wander away and give you their space. And so you can give them their space as well.
I've never been in a situation where I've been in danger from a bear, but certainly when you travel in some of the Alberta and British Columbia parks where they are regular, you go prepared in some fashion or other. And even just walking in a group goes a long way to making sure that if bears hear you as a group, they'll tend to get long out of your way before you're anywhere near them. It's a great question, guys. All right, Shani, time flies and you're having fun. So I want to highlight, we've got an amazing program coming up next week in our Peak Discovery series with the Burgess Shale, which is one of the coolest things for fossils in the whole world ever. And this program, if you want to share it with your family and friends, is right here. So much with Peak Discovery and so much with Waterton Lakes to discover on our YouTube channel, and I hope you will take that chance. Before we wrap up and say farewell to all our classes, is there any last message you want to leave our kids with today, Shani?
Just get outside, enjoy nature wherever that may be, whether it's Ontario or Alberta or India, all of the places that you're visiting from today. And thank you so much for joining me today.
Oh, nice to have such a diverse audience. It's such a thrill to have you as we wrap up our fourth program of the day today. Woo, we're all going to go rest now and do a magic spell of sleep, I think, by the end of the day. As you know, to wrap up every broadcast, we're going to bring in our classes to say a big thank you and farewell. Most of you folks are on YouTube, so if you want to scream and yell and annoy the principal, you have our permission. Ms. Eibel's class, Bayside, thank you so much for joining. Have a wonderful day. Bye for now, guys.